This tutorial is going to talk about section 7.5, proportions in triangles. And to get started, we have a brand new theorem. And it's called the Side-Splitter Theorem. And here's what it says. It says, if a line is parallel to one side of a triangle and intersects the other two sides, then it divides those sides proportionally. Once again, like a lot of these theorems, the wording of it is really kind of hard to understand. So let's go ahead and draw a picture and see exactly what this is telling us. So let's take this triangle for example, triangle ABC. Now the first part of this theorem talks about a line being parallel to one side of a triangle. So I'm going to go ahead and draw that in. So I'm going to put it right here. And I'll call this XY. And as you can tell, this segment or this line will be parallel to this one. So that takes care of the first part that says if a line is parallel to one side of a triangle. Now let's take a look at the next part. It said that it has to intersect the other two sides, which it does. It intersects right here at X and right here at Y. Alrighty. And then it says then it divides those sides proportionally. So a couple really vague terms here are it and those. What does it mean, it? What is dividing what sides? And what it's telling you to do is this. So this side here, okay, to this side. And let me write this out. So BX is to XA. So wrote that wrong. BX is to XA as, let's do orange, as BY is to YC. And that's all it's saying. So if you have this situation, if you've got this parallel line in here, and you have a triangle, then you automatically know that all these sides, all four of these sides, are proportional in this way. So let's take a look at an example to see how to work this out. So here in this example, we have this triangle over here. SU is my side splitter, as what the theorem is called. It's the line that's parallel to RV, and it's intersecting the other two sides, so we know everything is proportional. So when I start solving this, I'm going to go ahead and set up my proportion, and this is how I'm going to do it. I'm going to say X is to 16 as, let's see, what's the other pair? TU, which has a length, right? The length is 5, and then UV, which is 10. Now, this is not the only way that you can set this proportion up. Let's see if we can set it up a couple other ways before we start solving. Here are some other options. I could instead do X over 5 is to 16 over 10. I could do that just as easily. I could also do 16 over X is to 10 over 5. So there's no right or wrong way to write these proportions. Take a look at all of the cross products that we get. So in the first part that I did, over here in blue and purple, the cross products I get are X times 10 and 5 times 16. Take a look at the other options over here. Let's see if we get the same cross products. Here's X times 10 and 5 times 16. X times 10, 5 times 16. So as long as your setup results in the same cross product, we're all going to get the same answers. So let's go ahead and compute this. So this is going to give me 10 times X equals 5 times 16. And this is going to give 10X. 5 times 16 is 80. Divide both sides by 10, and X is equal to 8. So that's how I can use my new side splitter theorem to help me solve different sides of proportional triangles. Now, based off of what we just learned, we can draw yet another conclusion from it. And when we can draw conclusions from theorems, they're called corollaries. So here we have a corollary to the theorem, the side-splitter theorem that we just learned. It says if three parallel lines intersect two transversals. Let's go ahead and get that part sketched. I need three parallel lines. So I'm going to go 1, 2, 3. And I'm going to pretend that all of these are parallel because that's how I intended to draw them. I'll go ahead and put the arrows in here so that we know. So here I have three parallel lines, and they have to intersect two transversals. I'm going to do the transversals in orange. So I'm going to have one of them going like this, and one of them going like this. It really doesn't matter the direction that they're pointing as long as they're there. So we took care of the first part of this corollary. It says, then the segments intercepted on the transversal are proportional. What the sides that they're talking about here are here. This side is to this side, as this side is to this side. For example, let's give these sides some numbers. How about this guy's going to be 5, this will be my x, this will be 6, and this will be 10. Okay, so if I wanted to solve for x, I could use this corollary to draw a conclusion as to how to solve for this, and that is to solve a proportion. So I can say 5 is to, let's change it up a bit. Let's do 5 is to 6 as x is to 10. So this is really nice and useful, makes this solving very easily. So 5 times 10 is 50, and 6 times x is 6x. And when you divide the two, we're going to get 8.3 repeating. Or you could say 8 and 1/3. So either one of those is fine. So that's going to conclude this tutorial. Oh wait, never mind. I forgot one more. Sorry. Okay, so we've got one more theorem to look at, and it's called the Triangle-Angle Bisector Theorem. So let's take a look at that. All right, so this theorem says, with a lot of words, if a ray bisects an angle of a triangle. So first of all, I'm going to go ahead and draw a triangle. We'll just make him look like this. And then it says if a ray bisects an angle. Okay, so let's just pick this angle up top, and I'm going to make this look like I'm bisecting that angle, and it's just going to keep on going. So I can say that this angle here is congruent to this angle here. So if a ray bisects an angle of a triangle, we've got that part taken care of. Then it divides the opposite side into two segments that are proportional to the other two sides of the triangle. So here is the opposite side of that angle. So each of these sides individually, we'll call this one an x and this one y, they're going to be proportional to the other two sides of the triangle. And the other two sides they're talking about are here and here, which we can give them some names too. Let's give this one the letter E and this one the letter M. So if I can set up a proportion to help me solve if this situation arises. If I were to solve for E or M or whichever variable that I have here, and I have all of the others as real numbers, I can solve. So let me just show you real quick what a proportion would look like. I could say E is to X as M is to Y. And of course, once again, you can switch this up a little bit. You could say X is to Y as E is to M. Notice once again that all the cross products here are the same. And before I let you go, I have one thing that I would like to talk to you about. And I just want to go ahead and clear up one thing about simplifying radicals. And I'm going to use the number 180. When I break this down into my prime factors, this is what I get. And I don't think I explained this in the previous tutorial, so I'm going to tell you now. These are my prime factors of 180. 2 times 2 times 3 times 3 times 5. If you have more than one pair of numbers and you put them on the outside of the radical, what you're supposed to do with those two numbers is multiply them together. So this would be 6 square roots of 5. I just wanted to clear that up before I finish that off with you. That now concludes our tutorial.